problems are dealing with linear inequalities. That means we're going to have a line, only one. But because we are dealing with inequality, we've got to keep up with what the sign looks like. Sir?
I was just
Yeah, no. Share.
So, since it's like it's not an equal to,
Mm-hmm.
it's going to be dotted.
Okay, very good. So we're going to have a dotted line. If it has that little line underneath, doesn't matter if it's greater than or less than. If it's got that little line, it'll be a solid line. All right? Who else? And wait, one more time. What format does the equation need to be in? Y equals mx plus b. What's the b?
Where you start off.
It's where you start. It's the y-intercept. Well, okay, I'm going to ask this. Where's the y-intercept?
The y-axis.
Thank you, DC, because I have some people that are still looking at the x as the starting point. It's the up and down. What is the m? The slope.
Yeah, that's the.
Which is your rise over run. You go up or down, then left or right. All right. No, y over x.
Yeah, that's right.
All right. So you graph these, and then if they were purely linear, Will Skinner, that would be all you would do.
Yes, it would.
But since these are inequalities, how do we show what the solution is?
You solve it for that?
No.
Oh, you solve it.
Put on the graph.
We put it on the graph, and then what do we do to show the inequality?
You shade it?
You shade it. Excellent, Madeline. So if it's larger than, where do we shade? Above. If it's smaller than, less than, we shade below. All right, I'm going to say, I need you not to chit-chat. I'm trying to go through something real quickly for those that are leaving. So when we're going to keep working on those, but when we come to this third page, we have systems of inequalities. And let me tell you super quick what you're going to do. You're going to graph the first equation, just like it's a linear, just like it's a lonely equation by itself. And you're going to shade it like you would. Dotted versus solid, all the things that Levi said. Then you're going to go to the second equation. Do the same thing. Y equals mx plus b, solid or dotted. Set it up and draw it. And then shade it according to its inequality. The solution is where, please stop doing that and listen. The solution is where your shadings are crossing over each other, not where the lines cross each other. That would be the solution if it were an equal problem. But you'll have some shading, so I'm highly encouraging you to treat each line as a different color. And then, so if you have red going and then you have green going, you can find where red and green come together. And that's what I'm going to look for. It's that red and green being together. Okay? Alrighty. Track. Bye. Ladies, are y'all all here? Or any of y'all going to track? Okay. We're already recording it. All right, so y'all head out without talking so we can keep recording. Thank you. Be safe. So, the first one is set up. Y equals mx plus b.
So we get to the 1.
Go to the 1. I don't know who's chit-chatting, but I need the chit-chatting to cease. So we're going to go to the positive 1 on the y-axis, and we're going to do a dot. Then what, Emily?
Then you're going to go do like up 1 over 5.
Up what?
Or up 2.
Thank you.
Over 5.
Up 2. And when you say over, which direction is that, right or left?
Right.
Right. And then 1, 2, 3, 4, 5.
You can go down to and over 5 as well.
Okay, you have been in this class long enough. You know exactly what I'm about to say. And we're going to also go down to, thank you,
You're welcome.
and over 5. Now, if we were linear and it was an equal, well, it is linear, but if it were equal, we would just draw a solid line. Solid line. But it is not. It is a greater than.
So it's
So it's
solid.
dotted.
Dotted. So I'm going to just do some slashes to make this dotted. And I'm going to put my little arrows on it. This is a greater than or a less than? Which symbol is this?
It's greater.
Greater than. So, Madeline, where do we shade?
Above.
Above. And there we have it. We are good. All right. You do number 2. And because of what Will Skinner said a minute ago about, oh, we could go down and over to the left, you're going to have to do that. And the reason it works is 2 negatives make a positive. So going down is negative and going to the left is negative. Is this going to be solid? Charlotte, will this be solid or dotted?
Dotted.
Dotted. Did you start your graph with those points? Are y'all good with that? Okay. So then this is dotted.
I went up 2.
Well, if you start at positive 5,
Yeah, I went up 2.
up 2?
Yeah, no, I went up as well. That's what I'm.
Oh, well, you're going to be way off the graph, but that'll be okay. You'll go like 1, 2, 3, be right there, and then 1, 2,
Yeah,
3,
is it okay if we
4.
do both?
Of course, I highly encourage both all the time. And then keep going. It helps the graph to stay straight. All right, then Will Skinner, how do we shade?
Under it.
Under it. Excellent. All right, I think y'all have got a handle on that one. Number 3, we're not going to work, but would we shade above or below?
Below.
And would it be solid or dotted?
Dotted.
Dotted. What about 4, solid or dotted?
Solid.
And above or below?
Above.
Above.
No, we're not gonna do the back either.
Oh, yes, we're getting there. Number 5. Those were all set up, just kind of like 1 and 2. So I figure we would move on because this lesson is not about linear inequalities, but systems. So we're just doing a quick review on these. So, oopsie-doo. What do we do about number 5?
You put it in y equals mx plus b1.
And that means it's going to look like what, Will Skinner?
Y is greater than negative 4x plus 3.
Negative 4x plus 3. DC, where do I start?
Positive 3.
Perfect. And what is, Charlotte, what is the slope?
Oh, negative 4.
So it means I'm going to do what? How will I graph that?
Go down 4 over 1.
And over meaning which direction, right or left?
Right.
Perfect. Madeline, solid or dotted?
Dotted.
And are we going to shade to above or below?
Below. Oh, wait, above.
Above. Oh, I don't like my... There. Now, if you're... Just to make a comment, above is always greater than, below is less than. If you're looking at it and you're going, okay, how do I figure out above and below? You can take 0, 0, because that's always an easy ordered pair, and plug that in. So if you're looking at this and I'm going, I'm not real sure. So we're going to replace the x and the y with 0. So 4 times 0 plus 0 is greater than 3. And what's 4 times 0?
0.
0. All right, so is 0 greater than 3? Is that a true statement? No. Therefore, 0, 0 is not part of the solution. So when you shade in the area where the 0, 0 is not included. Does that make sense? So like you would have found 0, 0 right there, but because it made a false statement, we don't shade in that area. We'll shade over here. All right, look at number 7. Madeline, how do we set this up?
You have to move, number 7.
Mm-hmm.
You have to move, the 5x to the other side.
The what?
5x to the other.
Number
no,
7.
I was on 8, my bad. You have to move 3x to the other side.
Yes. So we'll have negative 2y.
And negative 3x on.
Thank you. And negative 3x plus 6. All right, what's our next step?
Now you have to, actually graph it.
Not yet.
No, not yet.
What would
Oh,
be
you
our
have to
next?
divide it by negative 2 now.
Okay, so what does that leave us with?
Now you have, now you have positive, now you have y, is greater than or equal to, 3 over 2 x, negative,
Mm-hmm.
minus, 3.
Perfect. I noticed that our original problem's less than or equal to, but you said greater than or equal to.
Because you have to flip the sign every time.
Ha ha ha. Excellent, Madeline. We divided by a negative. So if you end up multiplying or dividing by a negative, it flips the flipper. Perfect. So where, Emily, does this graph start?
Negative 3.
And DC, how do we continue the graph?
You go up 3 over 2 to the right.
All right. Then Charlotte, are we solid or dotted?
We're solid.
We're solid this time. And where do we shade? Okay.
On this side.
All right. So the initial problem is a less than, right? When we got it to y equals mx plus b, then what is it?
It's greater.
It's greater than. So the graph or the equation you use to shade or create your graph, that's the inequality you use for shading. So since it became greater than, we're going to treat it as a greater than. So
If you will shade on the right side.
that would be less than.
Oh, you said on the other.
Yeah, you're going to shade above the line. And again, you can plug in 0, 0 and see, and this time it would make a true statement. 0 is greater than negative 3 is what we would have. And that's true. All right. You do number 8. DC, let me know when you have the equation. Okay, what'd you get?
Y is greater than negative 5 over 3x minus 4.
Wait, so we're gonna start this graph at negative 5x.
For number 8, what's the B?
Oh, negative 4.
Right. Madeline, what's the slope?
Negative 5 over 3.
All right, if we're this low down, how do we show that? How do we graph the first point?
You have to go down about 5.
Well, I fall off the graph. Will Skinner, what can I do?
You have to
Go up and go to the
5,
left.
and then
And then which way?
to the left.
To the left, good. So up 5, but then to the left. As long as one of your fractional parts is negative, then it works. So, did we have to flip the flipper? Nope. So how do we, are we solid or dotted? We're dotted. And are we above or below?
Above.
Which in this case, is that left or right?
Left. Right.
Yeah, it'll be in this area.
Do we have activity period today?
No.
But after,
You have a 10-minute break. Here is your.
Oh, okay.
All right, going to kind of where we are with the lesson. All right, number 9. Oops, I did not mean to hit that. Number 9. 2 equations, they are already in y equals mx plus b format. I'm going to use 2 different colors. You could use a pen or pencil. Or if you don't have other markers, your shadings can be like squigglies or in circles. Or do something different for your shadings so you can easily find where they intersect. So my first one, I'm going to do blue. Starting where?
1.
1.
And then what's the slope?
Like 4 over 1 to the right.
Will Skinner, solid or dotted?
Dotted.
Dotted. So, how do we shade this one, Emily?
To the right.
To the, all
left. All right. I don't know.
right, it's,
You would shade it to left.
Yeah, left. No.
all right, it's less than.
Right, because
So let's put in 0 and see what happens. 0, 0. And that means we would have 0 is less than 1. Is that a true statement?
Yes.
So we're going to shade where the 0, 0 is a part of the equation.
so right.
To right. So I'm shading to the right. All right, I'm going to change color to do the second one. I'm going to use red. So it's already set up. Madeline, where do we start?
You have to start at -2.
Charlotte, what is slope?
Your slope is, wait, what did my slope be?
Don't say anything, please. This is for,
1, sorry.
it's for her to comment, not for
No,
assistance.
she did.
Okay, so how do I do that?
For my slope?
How do I graph it?
Oh, you start at 1.
Well, we're at -2. You start at B.
Oh, then you go up 1 to the right 1.
Up 1 to the right 1. Down 1 to the left 1.
Then you have
Is this going to be solid or dotted?
Solid.
solid.
If this were linear, if these were systems of equations, linear, equal, we would have a solution. You would have that dot. But it's inequality. So am I going to shade above DC? Will I shade above or below for the red equation?
Above, or no, below.
I don't know. It's one or the other.
Wait.
So for the second one, y is less than or equal to x minus 2. Am I going to shade above or below? You could do 0, 0 to find out.
Below.
Below. 0 is not less than -2. So we shade below the red or the solid. All right, now let's talk about what the solution looks like. It's not everything under the red. Okay? Because notice right here, there was no blue at that very bottom. So what the solution will be is when it stops at the red, at the blue line right here. And then it goes all the way across here. So I'm going to kind of darken that in even. So does that make sense? It's just where the red and the blue. So, I mean, I could get an eraser and kind of erase my solid blue up there, but if on a quiz, I will be fine as long as I can tell really, really, really where the two colors are. Charlotte?
We won't have our quiz though. This will be our test. We're not gonna have a quiz before.
I'll look in a minute. Right now, I'm trying to get this done.
Okay.
All right, number 10. You do it. No, you're right, Charlotte. There won't be a quiz, but there'll be a test. So on the test, the next assessment, I guess I should have said. Will the top one be solid or dotted?
Solid.
Be sure it's at, you start at -3 and not +3. All right, your line should look something like that. Are we going to shade above or below?
Below.
Below.
That one would be above.
It'll be above. So, Emily, where is the solution?
Still having a clue.
Have you shaded yours yet?
Yes.
Do you see where they
Would it be
cross?
like right here? That little-
It's going to be this little
Yeah.
bitty section right there, below the red, but above the green.
Okay, so like on this one, it would be that tiny little triangle too.
No, they would not include that. It's here. It stops. See how I got the black? It's here, not this. Because that would make it above the blue. If we took that in, it would be below the red, but it would be above the blue, and it's got to stay below the blue.
Yes, ma'am.
Yes, sir.
So if I like highlight that box, like that.
Oh, I love that. Oh, that makes it so easy to grade.
So like this one,
Great
so
idea.
So it would just be this part.
Mm-hmm. And then it would stop right there. We would not include that part.
Okay.
All right, so I like what Will Skinner did. he took a highlighter. Oh, let me go ahead. I did not do my green. And he drew with his pencil the box right here. And well, actually, he didn't fill it in, but he highlighted around there. So, perfect. All right. Let's see. Number 13. Do you want to do this one all by yourself? Or do you want to do this one together? All right. Charlotte, you want to do it by yourself or together?
I can do it.
Okay. Just remember, when you have it set up, because you're having to rearrange both of these equations. Remember, it's how the final equation you have is what you graph. How did you rewrite the first equation? Charlotte.
So for my first one, I got y is less than 4x plus 3. And then for my second one, I got y is less than or equal to negative 2x minus 3.
Okay, hold on. You got y is less than or equal to what?
Negative 3.
No. For the second equation, you got what?
I got negative 2x. I got negative 2x
Well, that's what I was trying to hear from her. Negative 2x.
minus 3.
All I heard was minus 3. That's why I was asking what else she said. All right. Agreed?
Yes, ma'am.
Everybody agrees? I do not.
The first one you need to switch the sign.
Why?
Because you
Divided by a negative. Good, Will Skinner. So, instead of less than, it needs to be a greater than. Oops, I changed, well, my color. So your graph should have looked sort of like that, but straighter. But then do you shade above or below?
You said for the first one?
The red one, I had the dotted one.
Above.
Above. And again, if you're not sure, put that 0, 0 in there. And you would have had y is greater than 3. And that's a false statement. So your shading would not include the 0, 0. Is the next one solid or dotted?
Solid.
Solid.
Yeah.
Notice it's really easy. If these were both equal, we would have a solution. They cross at -1, -1, but that's not what we're about on this. Do we shade above or below our dotted line, our solid line?
Below.
Below, it's less than.
Yeah.
All right, so for the solution, do you see it's all of the shading on the left except for the information below the red. So we would stop at this dotted red. We would not include this area below there. And then it would be all of this. Did that work? Pick one. 14, 15, or 16? Which one?
15.
15? Hop on it. right, did you get yours to look like this?
Mm-hmm.
And then the shading, though, is only this part. You've got to the right, the part to the left that's green is not included, and then the bottom part that is blue is not included. Are you good with this? All right. I do have a question. If they have same slope, does that make them, what does that make the line?
Same thing. Like, oh, infinite mini
It would be like.
They would be parallel. But that doesn't mean that doesn't mean no solution.
Infinite.
You're going to have to then look to see how the shading goes. Okay?
Infinitely many solutions.
That's going to be the exact same line, same line, same line. Like when you solve it, you have the exact y-intercept and slope. But your parallel will be same slope but different y-intercepts. And if you end up with that, that doesn't mean automatically no solution. Look to see how they graph. But here's the deal. Let's say, I'm going to draw one on here. Let's say for 16, we did end up with same slope. So we had one that looked like this, and we had another that looked like this. So if the solid were less than, it would go below it, and the dotted were greater than, you would have
Over at 9:05.
an area that would be just like this. But
Is
if,
there any on
that's why I did an example. I made one up. But if they ended up if you end up not sharing any shading, it would be no solution. Now, let me stop this. Your homework